So we had a fantastic panel right before us, and so I can see how it's all coming together. So we're going to introduce ourselves here quickly, but what we're going to be talking about is a health wearable using a sensor. So some taking a kind of a case study of an example of what they were talking about up here. All right, is this mic working? Okay, great. All right. So I'm Michelle Stewart. I'm a certified industrial hygienist at Chevron, part of their global technology company, and I'm located in California, San Ramon. So it was about a 45-minute flight to get here. I've been with Chevron for about 12 years, started in a refinery as a health and safety specialist, working there, climbing, scaffolding, you name it. Then I moved on to doing different things within health and safety, and then here now in the technology center where I'm doing a lot with R&D with HSC. So really understanding what are some of the problems or the issues that our workforce is having as barriers to their own health and safety, and what could we be doing to help alleviate any of that. Mike, if you want to introduce yourself.
Yes, my name's Mike Wasik, and I'm based out of Houston. I'm a health programs advisor, and have a varied background. I used to work for the University of Florida football team. I was the head athletic trainer, so I'd mentioned athletic trainers earlier. Thus some interest in this heat illness topic, and have been at Chevron now for the past 9 years.
Now, our colleague Selina was able to join us. I do realize I'm wearing the same shirt as my picture, so that's pretty classy there. Right. All right, so what we're going to go over why sweat. So why is sweat a way that we can understand a bit about people's physiology? And then Mike will also continue to talk about our sensor technology and the wearable landscape. And then I'll go over our proof of concept. So we've been actually doing this for about 3 years, and different evolutions of that particular idea that we're here to share with you. All right, here you go. Good, Mike.
So, how do you know when a worker is at risk for heat illness? Well, they could be at high risk because high temperature, high humidity, okay? And because of this, I don't know how much you've seen in the newspaper, but OSHA is actually working on some regulations to update what is going to be used with regards to standards for hydration and breaks and that type of information. You know, we end up looking at physiological as well as environmental monitoring. And then, you know, as Michelle said, we've been looking at this for the past 3 years, and we're starting to look at, you know, is it possible that maybe the standards that are out there right now, maybe they're not applicable as strongly with the population that we work with, which is oil and gas workers. You know, we look at them as industrial athletes. They're wearing a hard hat, football players wearing a football helmet. They're wearing fire retardant clothing, football players wearing shoulder pads, you know, other pads on there. So, you know, they are covered up and very difficult to get rid of the sweat and cool off like most people would be able to do if you're outside on a nice day like today with shorts on. So sweat helps cool the body. And then, you know, what we're looking at is fluid as well as electrolyte loss. So water and electrolytes. And I think sometimes people don't realize, you know, the importance that electrolytes have, and some of our data is showing, you know, the importance of that. Sweat could be an indication of heat illness. And, you know, you can, you know, there was a question that someone had asked in our poll about heat exhaustion. You know, there's different phases of heat illness, whether you start out with, you could get a heat rash or maybe some type of a cramp, and then go into heat exhaustion, and then maybe a heat stroke, which is a medical emergency, 911. But unfortunately, it doesn't go in that nice logical order. You can go from being okay in a couple minutes, it's a medical emergency. So very important. We want proper hydration. And, you know, again, what I'm on that second to last bullet, you know, it could be a medical emergency. So paying attention to people when they're having heat illness is very important. And then similar to concussions, you hear someone gets a concussion, they're a little more susceptible. Well, the same thing happens with heat illness, we've discovered looking at different bits of information. So sensors and wearable technology. And so what we are using is a patch, which is down on the lower right, that has a module on top of it, as well as an app. And it has a programmed, personalized hydration algorithm. And we're looking at height, body weight, birth gender, clothing type, sweat loss, electrolyte loss, temperature, and motion. Not that big, as you can see by the dimensions. And what are we measuring? We're measuring the sweat loss, the electrolyte loss, skin temperature, motion, site temperature, and humidity. And then what we're trying to do is have real-time status so that the people know on the spot how much fluid they lost so they know what to replace. And we've also added in some vibration alerts where if you get a short burst, that means that you've lost a bottle of water. So 16.9 ounces typical bottle. If there's a longer vibration, that's if someone has lost 2% of their body weight. So we're trying to help them say, you know what, you need to take a break and rehydrate. So we have done a couple proof of concepts. In 2021, we tried to look at the Wibjit, the wet bulb globe thermometer versus the sweat patch. We were trying to look at the sweat variation within the population, as well as get worker feedback and impressions. We just heard previously, involve the worker. Well, we, every step of the way, have been involving the worker. We did one in California and one in Texas. And when we were in Texas, we had beautiful weather. And beautiful weather for this type of study is hitting 105 heat index every single day. So, the prime conditions. 2022, we started to look a little bit more at, did these improvements help and what feedback did we get? So we are looking at sweat fluid loss to fluid replenishment using this app. We are looking at the technical fluency of the workers. We're also looking at the infrastructure needs because, okay, we've got this patch, but we're working in the oil and gas environment. Is the infrastructure set up that we can use the patch and the app so that the Bluetooth as well as the internet works to communicate with one another? And then looking at the different dashboards that would appear. And so for this past summer, we worked with, we had 152 applications that were our offshore Gulf of Mexico and 171 applications for our onshore Gulf of Mexico. And I'm going to turn over the results to Michelle.
All right. Thank you, Mike. So one thing about an oil and gas environment is we have some requirements, right? So we need to have something, if it's going to be on someone and they're going to be in an environment that possibly has hazardous environments, they need to have a Class 1 Div 2 certification. So that's been some of the things we've been able to overcome. Another thing too is they can't bring that cell phone with them, right? So how do they know that it's time to drink a bottle of water? And that's where those vibrations come in, where you don't have to have the cell phone on you to know when it's time to drink water. And so these are some of the requirements that came up through having conversations with the workforce and conversations with leadership. One thing that we also wanted to point out to folks is in thinking about the traditional methods that we use to try to even identify heat stress is we think everyone reacts to the heat stress the same. And so one of the objectives of our proof of concept was to demonstrate that that's not true. So if you take a look here, this is an example of data from our work, from one of our trials sessions, where you can see how much people sweat. So it goes from folks who are mild sweaters all the way to significant amount of sweat. And so if you're trying to build a program, so I'm putting my health and safety hat on and I'm trying to develop a heat illness prevention program, I can use this data to be able to say, hey, we need to have enough water available for those who are mild sweaters to heavy sweaters. People are doing different types of work that's going to be getting them to work different ways, and that's what we're going to be seeing. So that's some of the data that we're able to share because we have now a personalized wearable to show our management and the workers as well. What's kind of neat is the folks who were part of our trial. So again, volunteers, champions of technology. And you'd see them after a day of work going, how much did you sweat? How much did you sweat? It was really fun. And I'd be like, okay, well, it's about baseline. Now you sweated. Now did you drink enough water? right? So that kind of got us some ideas about gamification potential, trying to keep people doing this for long term. Some of the proof of concept that we wanted to do. So in 2021, our study was 3 days, right? We were there on site. They're doing it because we're there, right? But what happens when we leave? Are they still going to wear it? And that was some of what we studied this year. We had about 3 weeks, 3 to 4 weeks of people wearing it. We saw some consistent use, some inconsistent use, and that's that right there. That's a nugget of information for us to understand. Well, what would have made you wear it longer? Why did you wear it as long as you did? So that's some of that feedback conversation that we're having with folks, and it's been very productive and very insightful. So one of the things that someone had mentioned the panel about when you do a proof of concept to start small and have that quick win, right? So for us, it was identifying that there is potential dehydration happening within our population, and potential dehydration could lead to heat illness. And when you ask folks, how do you detect heat illness within your work? How do you know that you're experiencing heat illness? They're like, oh, I have nausea, or I get or they're all these symptoms that they're describing. Well, if you're already experiencing those symptoms, me as a health and safety specialist, I failed you, right? I want to be able to catch that before you start experiencing those symptoms. So that was one thing that we wanted to show through this proof of concept, that people are experiencing potential for heat strain. So if you look, this should be a 1-to-1 is what we should be seeing here. So I've lost, let's say 2,000 milliliters. I should be ingesting 2,000 milliliters. So anyone below that line there experienced we're in a dehydrated state. And for this particular study, it was where we were measuring their sweat, but verbally we would ask them, what did you drink today? How much did you drink? So we didn't have that kind of accurate input. This year, though, we were able to modify the app so that they could input that information themselves. And we saw kind of a similar trend here. And actually, we saw, I think, more potential dehydration folks. Mike touched on the other aspect that we found was the infrastructure around our workplaces to be able to support this type of technology and support the workers and the use of it. So kind of looking at the fluency, we saw a variation of fluency. Different language barriers was another area that we learned that we need to address. Even access to the mobile devices. So I mentioned how some locations, they cannot bring their phone into their work location. And some of them, they have to keep it in their residence quarters. So if our goal is for them to use that as their interface, how do we solve that solution? One thing that we saw is a supervisor say, hey, you can keep it in my office, and in between breaks, you can come and fill it out. So that was really neat to see the supervisors kind of shifting a little bit. Other was connectivity. Any of you been middle of the ocean? It's kind of hard to get a signal out there. And when the signal goes out in the entire plant, guess what? It's not coming back for a few days. So really understanding how do we struggle around that, and what do we need to be successful in this space. And then reliable feedback. So some of the opportunities that we had was when we weren't there on site and things were maybe not going as expected. We weren't there on site to really understand what was going on and how that was impacting the person's impression or the use of the tool. So really figuring out how we can get that really good feedback. And then data privacy and cybersecurity. So working real closely with the startup to ensure that we have the data privacy requirements in place, working with our own internal folks. So when we're helping to design this product, we were designing it with data privacy in mind, as well as cybersecurity. So that has been a big success for us. One thing, though, I learned is that it is definitely in different regions, is the requirements are different throughout the world. All right. So this is our journey. Really, we started with what's called a discovery patch. I believe someone mentioned you don't need batteries, and that's very true. That's what happened here. This is just a sticker. You stick it on, and it uses a colorimetric device there. The thing for us, though, is that we needed our workers to have that real-time feedback. And for that to work, you have to apply it onto your arm and you have to roll up your sleeve to see what the results were and take a picture. And that wasn't going to be feasible for our workforce. So then we went to the connected hydration patch 2, where we now had some detection and it was being fed to a app. But however, they couldn't see it or understand it or interpretate it. And then now we have what we're trialing out now. So our goal is to have our MVP trial next year, hopefully in Australia, because it's a little hot there. And then who knows what the future holds. I know we've been different we are a global company, and so places like Singapore, Bangladesh, Kuwait, we've seen some opportunities there. But again, the cultures are different, and that's where we're going to learn is embracing the workforce and what their unique requirements are. All right. Do we have time for questions? Yes. And I know there was one here asking.
There was one on heat exhaustion that we saw. And so it's not necessarily where we are able to predict whether someone's going to have heat exhaustion. It's more for this tool is used to help reduce the risk of a potential heat illness by staying hydrated appropriately. There's not I wouldn't say there's a correlation with the body temperature and the sweat. Each person, as Michelle had said, sweats differently, and it didn't matter by size of person either. There could be some people that were big guys and didn't sweat as much, or other guys that were pretty big guys and sweated a lot, and vice versa. Over time, yes.
So we didn't measure internal core body temperature, which is what you would be indicative of a heat strain or heat illness. What we did measure was skin temperature. So it's the temperature between their skin and the PPE that they're wearing. And something that we saw that was really interesting, because we also did our WIBJIT. So we put a monitoring device, which is traditionally used by industrial hygienists within the workspace to predict what their work rest cycle should be. And we put it out there, and we saw that even in that micro environment, it was not detecting or predicting what their temperature, what they were experiencing based on what was underneath their clothing. We saw about 10 to 20 degree difference of what the ambient environment was saying versus what was experienced in their clothing. As far as a correlation between sweat and core body temperature, there is data around that the team that we've been working with have. We'd have to pull up the journal article for that. Another thing that we looked at was around how do we compare what the sweat is recommending as far as hydration versus what our traditional OSHA or NIOSH calculations are recommending. And what we found is that it is being more personalized to that individual. So that was one thing that we tested as well. You're welcome.
What did you do to protect people's personal information from, HIPAA concerns and legal requirements?
Yeah. So one thing is it's found out it's not HIPAA, believe it or not. The other part too is we used informed consent. So this was as far as the study. We did blind all the data. So I myself, if I looked at information, I would have no idea who that person was, even if I met them. And then so we worked with our partner they have the data, we didn't have the data. So that was part of that control there.
Yeah, and the other part of that is, it's a American Disabilities Act issue that we were dealing with. And so what we had originally planned, so you go back to 2021, we wanted to have everyone on a tablet so that if someone is working, a supervisor would be able to say, hey, this person is getting into a red zone, let's get them some hydration and rest. But we couldn't do it from that perspective. And that's still something that people would like, especially, we've got people that go into confined spaces and that. So it's something that, this is a new world with what we're doing. Maybe some things start to change down the road, but that was something that we had hoped to try to do, but we're not able to.
And what that boundary or that requirement gave us was the vibration. That's how we came up with the vibration. If we couldn't have someone monitoring their status, we need them to be able to self-monitor. Yes.
Just out of curiosity, is this a product and solution offering? that you guys have, or is this? I mean, Southwest Airlines. We have a lot of people in heat.
Yeah, so this right now is a proof of concept. We are working with a particular partner. It's a startup. Chevron has invested in them, so we're hoping that they would have something to market by next year. Anyone else? Yes.
Does the placement of the device matter? Meaning that I mean, I'm assuming people sweat at different rates in different places of their body. So how accurate can it be? Just out of curiosity.
Well, there's been a lot of different studies with regards to where you can get the best sweat. And the way this is designed is that it rests on your arm between, basically, if you put your arm at 90 degrees, right between the bicep and the tricep, right along the side of your arm. That's where it's designed. And there's a couple other places that they have looked at, but you can look online and see what the different parts of the body are that sweat. But that's where this is designed to be. And part of what we looked at was making sure that was a good spot, that it wasn't going to be getting knocked around and fall off. And so far, we've been very happy with that spot.
Yeah, we also want people to be able to put it on themselves. So other locations are like the back actually is a really good spot, but I don't see people doing that. And then the forehead is a good one too, but I don't know how good we are about walking around with something on our forehead. So, all right.
All right. Thank you very much.
Okay. Well, thank you so much.